Hello and welcome to this short video on representing ranges on a number line. So before we start, of course, we need to know what a number line is. If you don't know this, well, this is what number line is right here. It is this structure which I have drawn here, where we have 0 somewhere in the middle, and we represent numbers on this number line by their position relative to 0. We call this direction to the right the positive x direction, and this direction to the left the negative direction. We can represent numbers like this. If I call this 1, then this would be 2 because they have to be equidistant, like this 1 2, and then the next number after that would be 3. This would be 3, this would be 4, this would be 5, this would be 6, this would be 7. And because we cannot go infinitely, because we have a finite amount of space on our sheet of paper, we draw an arrow on the right hand side and say this thing continues to infinitely. So there's a 8 here, there's a 9 here, and so on. But since we cannot draw them, we just draw an arrow here indicating continuation. Similarly, on the left hand side, 1 less than 0 is negative 1, and then we have negative 2, negative 3, negative 4, and so on, negative 4, so negative 5 over here, so negative 6. And because we cannot infinitely continue in this direction, we have to terminate it here and just put an arrow to indicate that there are more numbers, we just cannot represent them on this finite space. So here, on this system, if we want to represent a number, what we do is simply put a dot where we choose. Let's say I want to represent a number 2, then on the number line I'll put a dot at number 2. This red dot is representing the number 2. If I want to represent a number negative 5 divided by 2, as in negative 2.5, that would be this point right here. So this is negative 2.5. If I want to represent the number 5, that would be this number here, so that's 5. So here you can see, with this system of just putting a dot wherever you choose, you can represent single points of numbers. What if instead you want to represent a range of numbers? What if on this number line, let's say I have another number line like this, I want to represent all the numbers, let's say all numbers between 1 and 2, let's say. If I want to represent all of these numbers, how could I do it? Well, you might think one way to do it would be to just write the number 1, write the number 2, and start drawing points in between 1 and 2. So you'd start like this, draw this point, draw this point, draw this point, draw this point, and so on. And you're kind of right, that is part of the way that we actually represent these set of numbers, but we do it in a different way. So what I mean by all numbers between 1 and 2 are the numbers that are greater than 1, i.e. let's call this number, let's say x greater than 1, and the values of x that are less than 2. So we want to represent this range. Representing this range with the brackets, we can write that this is same as the range of 1, 2. And notice the curly brackets indicating exclusiveness. If I had square brackets here, that would indicate inclusiveness, meaning that the actual endpoints are also included in the range that I want to write. So, on a number line, the way we represent this kind of range is with 3 symbols: the whole, the dot, and the shaded line. So here, what the whole represents is non-included points. What the dot represent is an included point, and what the line represent is ranges between points that are included. So in this case, the important points that we have to write within this range are the points 1 and 2. Both of these points are excluded, which means we have 1 excluded, which means there's a whole around 1, and we have 2 excluded, which means there's a whole around 2. Now that we've marked all the important points, we also need to mark all the important ranges in between, which is where the shaded line comes in. So in the case of this thing, we want all the numbers between 1 and 2. So therefore, all numbers between 1 and 2 should be shaded. So along this line between 1 and 2, we need to shade this like this. So what this here represents, what we've drawn on the number line, represents exactly what we wanted initially, all the numbers that are between 1 and 2. So here you can see there's a whole at 1. The whole at 1 indicates that the values at 1 are not included, i.e. there is no value of 1 within this range that we want, because of course 1 is not between 1 and 2, and similarly 2 is not included because, well, 2 is not between 1 and 2, but all the other numbers that are between 1 and 2 are included as seen from the shading in between 1 and 2. If let's say we want all the numbers that are between 1 and 2 but including 1, this would be a little bit different. Let's say we want all numbers between 1 and 2 including 1. So here we want to include 1 in our range for whatever reason. If we wanted to do that, we have to write this in a different way. Recall the dot is how we indicate inclusiveness. So here if I have the same thing, if I write 1 here and 2 over here, this time because I want 1 to be included, 1 needs to have a dot around it. So 1 has a dot, but here 2 is not included. So therefore 2 has a hole around it, and because we want all the numbers between 1 and 2, all the numbers between 1 and 2 also need to be highlighted. So we need to have a highlighted shaded line in between 1 and 2. This is how we would represent all the numbers between 1 and 2 including 1. If you're curious about the set notations of this thing, we want x greater than or equal to 1 and less than 2, which is the exact same as writing x being in the range of square bracket 1 comma 2 curly bracket. So here the square bracket indicates that 1 is also included in our range, and the curly bracket on the 2 indicates that 2 is not included in our range. So here you can see each of these three translate in between each other. We can have the set notation in this form, we can have the range notation like this with the brackets, and we can have the representation on a number line. Similarly for the above range, the set notation is like this, x in between 1 and 2 corresponding to the range notation of 1 comma 2 with curly brackets around them, corresponding to the number line notation, which is hole at 1, hole at 2, and shading in between 1 and 2. We can of course use this to represent more complex ranges. Let's say for all x's that are between negative 4 inclusive, let's say negative 1 exclusive, this range of values, or let's say another range of values between 0 exclusive and 2 exclusive, with the added condition that x is not equal to 1. Let's say we will have some crazy expression like this. We can represent this on a number line as well. To do this, we just need to draw the number line. We'll draw all the points of interest, which in this case are negative 4, negative 1 is also a point of interest, 0 is a point of interest but it's already drawn, 1 is a point of interest, and 2 is a point of interest. So now, to write this down, we need to first break down each of these expressions and slowly create our final expression. So we can see, going from outside to inside, we have an intersect here, which means both of these conditions, the condition on the left and the condition on the right, need to be true in order for the full statement to be true. So therefore the condition on the right needs to be true. So x is not equal to 1. If x is not equal to 1, x could be any value other than 1, which means there's a hole at 1 and all other values for now are possible. But now, given this, we can only say that x is not equal to 1. On the other side, we have a bunch of other things. X could be between negative 4 and negative 1, or x could be between 0 and 2. So here, if we write each of these ranges between 0 and 2, both exclusive means a hole at 0, a hole at 2, and all the values between 0 and 2. And note, because we already have x not equal to 1, x cannot be equal to 1, which means we cannot actually shade like this. We need to instead skip the point at 1 and shade the rest. We could have this. Or we could also have x being between negative 4 inclusive and negative 1 exclusive. So in this case, because negative 4 is inclusive, there needs to be a dot at negative 4, and because negative 1 is exclusive, there needs to be a hole at negative 1, and we shade in between these two. So here, this is the set of values corresponding to the expression above here. X could either be between negative 4 and inclusive and negative 1 exclusive, or it could be between 0 and 2 both exclusive. But no matter what, x cannot be 1. So given all of these conditions, the correspondent shading on the number line is this. I want you to perfectly understand what each of these symbols are and how we translate it between the top expression and the number line representation as drawn here. So here we can see, here we have an intersect, which means this always needs to be true, and given that it cannot be 1, and this also has to always be true. Within this thing, because we have an O here, this could be true or this could be true. So one or the other, which means we need to take both of them all together. If instead of an OR here, if we had an AND here, then what we would have to consider is the overlap of these two, because both of these need to be true in order for the overall expression to be true. In which case there is actually no answers within the range, because considering this thing, that would mean that the only valid values are when this range overlaps and this range overlaps, which we can clearly see by the number line never happens. Because of that, if this was an AND instead of an OR, this would have no solutions, but it fortunately is not. This is an OR, in which case there are solutions, and these are the solutions as drawn on a number line and as written in set notation text. So a handy way to identify this kind of creation using set notation and turning set notation into number line notation would be to do something like this, would be to take this expression, break down each of the individual components of the expression and try to separately draw each of them. What I mean by this is, within this thing there are certain sets that we can easily draw. One of those sets is this one, which I'll call set number 1. Another set which we can easily draw is this set, which I'll call set number 2. And another set which we can easily draw is this set, which I'll call set number 3. We can easily draw 1, 2 and 3, but we cannot necessarily easily draw the combination of 1, 2 and 3 as given by these unions and intersects. So what we could do is to simply try to draw each of these individually, do the operations on them, as in the intersect operation and the union operation, and then construct the final answer. If you cannot do it in the head, this is the method that you would have to follow through with in order to get the correct answer. So here we have 3 number lines that I have drawn. We'll call the first number line the representation of the set 1. So here we'll have 1. The second number line will represent number 2, and the third number line will represent number 3. And then we can do the union and intersect operators on each of these to try and figure out what the overall final expression should be. So considering 1 is all the x's between -4 and -1, which include -4. So drawing the points of interest, we have -4 over here. Let's say we have -1 here. Then the green set is going to be -4 inclusive, -1 exclusive, which means whole at -1 and all the points in between. So this right here is the shading that represents the points correspondent to the range 1. How about 2? Well, 2 is all the points that are between 0 and 2. So here if we draw here the point number 2, and then we try to draw the range of 2 on this number line. On the second number line we have that 0 is excluded, 2 is excluded, and all the points in between 0 and 2 are included. So we have to shade between 0 and 2. This is the range corresponding to the second equation. For the third equation, what we have is that all the points other than the point 1 are included, because x is not equal to 1. So therefore, if x is not equal to 1, there's a hole at 1, and every other point on the number line is included. So we just shade all of this. All of these points are included. To the left hand side as well, all of these points are also included. So now that we have this, now that we've broken this expression down into its simplest components that we can easily solve for, we can add these together based on the union operators and intercept operators within the expression in order to get the final answer. Again, if you have the ability to do it in your head and identify which ranges are valid, you should do that way. This is just in case you cannot do that. This is an easier, more straightforward way to directly do it. It of course will take more time and more effort, but it is the way that you can do it if you cannot do it in the head. So what we first need to do is to do the union operator of 1 and 2. So here between 1 and 2 there needs to be a union operator happening here. So in a union operator, what we have is the all the values of a or all the values of b, meaning we just take all the values of a, take all the values of b, write them on top of each other and take that as the final result. So if we just take 1, we take the number line 1, we overlap it perfectly with number line 2. This is the correspondent set of 1 union 2, which I will actually erase this thing on the left here and write this as 1 union 2. So I'll put 1 over here, 2 over here, and this set that we've drawn here is 1 union 2. Now that we've done 1 union 2, we're out of this bracket. Now we can do the final thing, which is 1 union 2 intersect 3. So intersection is basically the overlap. So what we need to do is overlap all the values of 1 union 2 with the values of 3, and I've drawn a separate number line which we can do that on, because if we try to do it directly it might cause a little bit of troubles. So the last thing we're going to have is 1 union 2 whole thing intersect with 3. So where does 1 union 2 overlap with 3? It overlaps over here at -4, so we can see it overlaps at -4, which means the one of the interest points is -4. Similarly, -1 is also an interest point, so is 1, and so is 2. Considering this thing, since 3 exists at -4, and it also the equation 3 exists at -4, similarly 1 union 2 exists at -4, we can say that -4 needs to be shaded in 1 union 3 brackets intersect 1 union 2 brackets intersect 3. Similarly, if we consider -1 does not exist in 1 union 2, but it exists in equation 3. So therefore there needs to be hole over here, and there needs to be shading between these two, because all the values in between -4 and -1 are included in both equation 1 union equation 2 and equation 3. How about the other one? Well, 0, the point 0 is not included in 1 union 2, so therefore there's a hole here. Similarly, the point 2 is not included. Similarly, the point 1 is not included in equation number 3, so therefore all of these 3 points are not included. But considering the overlaps, these two ranges, which are the ranges from 0 to 1 and 1 to 2, are overlapping in both of these functions. So therefore we should have the range from 0 to 1 being shaded in on the final answer, and similarly the range from 1 to 2 should also be shaded in. As a reminder, I will say this once again, this method should only be used if you really cannot do it in the head and try to figure it out on your own. Otherwise, of course, this is going to give you the correct answer, and it's going to give the correct answer without mistakes, provided of course that you do the addition of union and intercept correctly in between each of these. It's really not that complicated to do. You just need to apply basic understandings and the idea of union and the idea of intercept. Union is the OR operator basically. It's when either one or the other of the two are true, which i.e. you just take one, put it on top of the other and find the common regions. And the intersect operator is where there's an intersection or an overlap between each of these. So in this case, for the intersect of 1 union 2 and 3, there's overlap here, there's overlap happening here, and there's overlap happening here. So we draw all of that, and as the final answer we have this range given down here, which is exactly what we found earlier. It's just I'm showing you that if you cannot do it in the head, you can do it piece by piece and build it up. So that's the summary of this video, and also the end of this video. The only things that we need to note here are that the dot represents inclusiveness, inclusive point. The hole or circle represents an exclusive point, meaning we don't take that point into the range. And shading is showing an included range. Also note, shading is always done between known points, i.e. let's say the circles between circles and dots, or between dots and dots, or between circles and circles, except one situation where we go towards infinity. You will see here in the case number 3, when I wrote x not equal to 1, you can see on the far right side and on the far left side I did not have a dot or a circle corresponding to the very end? Well, that's because this line theoretically needs to go infinitely in this direction before it meets any dots. It will not meet any dots because it has to infinitely go into both the negative direction and the positive direction. Other than that case where we're going to positive or negative infinity, in all other cases, these included ranges, these shaded lines, should always be between included points or excluded points. So that's it. Each of these have their own meanings. We need to understand each of these meanings. The dot is an included point, the circle or hole is an excluded point, and the shaded line is an included range. Using this and the decomposition that I've taught here, you can construct the representation on a number line corresponding to any conditional range, or let's say some range expression like what we have over here. So that's it. I hope this video was helpful to you in understanding how we represent ranges on number lines. And if you have any other questions, please comment down in the comments down below. And thank you for watching, and goodbye.